about this program. This program answers all your questions about dinosaurs and their long reign on Earth. It's packed full of fun facts about these fascinating creatures. Which dinosaurs were the biggest, smallest, cleverest and dumbest? What did dinosaur babies look like? Could dinosaurs run, fly or swim? These are just some of the questions that people ask about dinosaurs. In this program, all those questions will be answered. Also, find out how scientists prepare dinosaur fossils and put skeletons together. There are many tips on how to collect your own fossils and where to go for more information. What are dinosaurs? Dinosaurs lived millions of years ago. They were reptiles, a group of animals that today includes lizards and snakes, turtles and tortoises, crocodiles and alligators. Dinosaurs lived only during the Mesozoic era, or so-called Age of Reptiles. The Mesozoic era lasted from 228 million to 64 million years ago. No one has ever seen a dinosaur. The earliest of human ancestors did not appear on Earth until 4 million years ago. There were many different types of dinosaur. Scientists have grouped them into several sorts. They are theropods, all the meat-eating, two-legged dinosaurs like Tyrannosaurus. Sauropods, the giant plant-eating dinosaurs like Apatosaurus and Diplodocus. Ornithopods, smaller plant-eating dinosaurs which walked on two legs like Iguanodon, and the duck-billed dinosaurs or hadrosaurs such as Syntosaurus. Ceratopsians, the horned dinosaurs like Triceratops, all plant-eaters. Stegosaurs, the dinosaurs armed with plates like Stegosaurus. They were plant-eaters and walked on four legs. Ankylosaurs. This group includes other armed dinosaurs like Nodosaurus. Like the stegosaurs, they were plant-eaters and four-footed. Pachycephalosaurs. The name means thick-headed and describes a group of dinosaurs with very thick skulls named after the best-known Pachycephalosaurus. Many other types of reptile lived before the dinosaurs. The very earliest reptile that scientists have recognized was found in Scotland in 1989. The fossils were found in rocks and are believed to be 335 million years old. Tanystrophus was a 3-meter-long early reptile which had an extremely long neck. It lived 250 million years ago. Although the dinosaurs all lived through the Mesozoic era, different sorts lived at different times. Sauropods first appeared around 228 to 130 million years ago and lived right up to about 64 million years ago, although by this time there were not as many. Ornithopods didn't begin to appear until 130 to 95 million years ago, but their numbers increased about 60 million years later. The ceratopsians, on the other hand, were much later and didn't come about until 95 to 64 million years ago. Many people wonder where dinosaurs came from. Fossil evidence has shown that a group of reptiles living in Argentina about 230 million years ago developed a new way of walking. Instead of walking with sprawling steps like crocodiles, they began to walk with their legs more directly under their bodies, like the dinosaurs. One reptile called Lagosuchus may have been the ancestor of all the dinosaurs. An unusual early reptile was Longisquama, which lived in Asia 240 million years ago. Only 15 centimeters long, its back carried a row of stiff, tall scales. There are two important features of a dinosaur. First, they all lived on the land. Second, they all walked on upright legs. All other reptiles, whether fossil or living, had different ways of moving. Now, what is believed to be the world's oldest dinosaur was found in Argentina in 1991. Named Heraptor, it lived 228 million years ago. It was over 1 meter long, perhaps the size of a large dog. Other early dinosaurs have been found in South America, and even older ones may still be discovered. So where did dinosaurs live? Dinosaur fossils have been found on every continent, even in Antarctica. But since dinosaurs first appeared on Earth, the positions of the continents have changed a great deal. The continents have been drifting apart slowly ever since they were first formed. North America and Europe are drifting apart from each other about as fast as a fingernail grows. Today, Brachiosaurus can be found in two continents, Africa and North America. When Brachiosaurus was alive, it was still all one continent. No single type of dinosaur lived everywhere. Some groups of dinosaurs were more common than others. Plateosaurus belonged to a small early group called prosauropods, and close relatives have been found in the USA, Germany, South America and South Africa. It's thought that Plateosaurus travelled in herds, as large groups of skeletons have been found in Western Europe. Some herbivorous dinosaurs may have migrated in search of fresh grazing. Tyrannosaurus rex, on the other hand, the dinosaur that everybody knows, has very few skeletons found, and most are incomplete. These were all found in the USA, mainly in Montana. The most famous dinosaur finds have been made in what is now the USA, South America, Canada, Tanzania, Mongolia, China, Australia and India, as well as many European countries. Dinosaurs would have lived somewhere where they felt safe. Small dinosaurs would perhaps nestle in sheltered spots away from their enemies, whereas the larger dinosaurs may have had favourite resting places on the edges of forests or beneath cliffs. Those dinosaurs that lived in the Antarctic would not have been as cold as some of you might think. As the Earth's climate was so much warmer then, and Antarctica was much nearer to the equator than it is now, the dinosaurs would not have seen any ice caps. Reptiles cannot survive very cold climates. Which dinosaurs were found first? Early in the 19th century, some strange fossils were found in southern England. They were recognised as being from creatures entirely new to science. No one really knew what these creatures looked like. When Gideon Mantell, a doctor from Sussex, first showed his dinosaur teeth to other scientists of the day, they were identified as being from a rhinoceros. Later on, though, in 1822, he found the teeth of Iguanodon, so called because its teeth looked like giant versions of the living marine iguana from the Galapagos. In 1824, William Buckland described some bones which he called Megalosaurus, but had found some years before. After these discoveries, many people began to hunt for the fossil bones of these new giant lizards. Bones were found many years before, but no one realised that they'd once belonged to huge, extinct reptiles. One bone was even thought to be from a giant man. For hundreds of years, the Blackfoot Indians of Canada thought that the dinosaur bones they had found were the remains of their ancestors. Chinese doctors had been collecting dinosaur teeth for over 2,000 years. They believe they come from dragons, and the teeth are ground into powder and used for medicines. Gideon Mantell drew the first reconstruction of a dinosaur in 1835. He first thought that Iguanodon must have been like a giant lizard, 21 metres long. We now know that it's about 10 metres long. In 1854, several life-size models of dinosaurs were built in the gardens of Crystal Palace, London. Iguanodon is still there today, looking rather like a rhinoceros. One of the most spectacular finds ever was in 1878, when almost 40 skeletons of Iguanodon were found in a coal mine in Belgium. Huge numbers of dinosaurs have been found in North America. The first was an early sauropod called Ankylosaurus, found near Manchester, Connecticut, USA. Some fragments were found in 1818 and were thought to be human. By 1855, it was decided that they must be reptilian. Dinosaur means terrible lizard. The name was invented by a scientist called Richard Owen in 1842. Each dinosaur is given a special name using words made up from two ancient languages, Latin and Greek. The names usually mean something which describes the creature in some way. Megalosaurus means big lizard and was also the first dinosaur to be given a scientific name. The same dinosaur names are used by scientists of all nationalities. did dinosaurs look like? When complete skeletons are found, scientists can be fairly sure that they can put the bones together in the right order. But could we guess what you look like from just your skeleton? Scientists use their knowledge of other animals to put dinosaur skeletons together. But for a long time after dinosaurs were first discovered, many mistakes were made. Apatosaurus even got the wrong head for nearly 100 years because it was originally found without one. It was difficult to tell if a dinosaur was fat or thin, as fossils are usually just the remains of their hard parts, normally bones and teeth. Modern plant eaters, such as elephants, hippos and cattle, have big stomachs, and plant-eating dinosaurs were probably just as fat. Smaller, more agile dinosaurs needed to be slimmer to move quickly. Scientists and artists have to use comparisons like this to get an idea of how each dinosaur might have looked. Earlier this century, some scientists thought that the legs of Diplodocus sprawled like a lizard, but its chest would have dragged along the ground. Perhaps the smallest dinosaur was Compsognathos. Fully grown, it was only 70 centimeters long. Most of this was a long tail. We can never be sure what dinosaurs looked like. Scientists still argue about the way many dinosaurs might have appeared. Even well-known dinosaurs like Iguanodon can be made to look quite different when drawn in different poses. Gideon Mantell thought that an odd spike-shaped bone he found must be a horn on the nose of Iguanodon. It turned out to be a thumb. A few fossils of dinosaur skin have been found. It was tough, dry, waterproof and made of small rounded scales. Sometimes there's armor plating. Even fossils of skin cannot tell us what colour dinosaurs were. Modern reptiles, especially the lizards, have a wonderful variety of colours and patterns, and dinosaurs may have been just as colourful. Bright patches of colour might have been important for the dinosaurs to recognise each other and to display warning signs. The large plant-eating dinosaurs were probably camouflage, but would we have guessed at the zebra's stripes with only bones to study? Machmenschiosaurus was 22 metres long, but 10 metres of that was its neck. It lived in China 160 million years ago. The largest complete skeleton known is of Brachiosaurus, 12 metres tall, 23 metres long, and weighing 70 tons. The longest dinosaur known is Diplodocus, whose skeleton was up to 27 metres long. But some new finds from Colorado and New Mexico might be from even bigger dinosaurs. Superosaurus, Ultrasaurus, and the largest, Seismosaurus, were truly gigantic. Seismosaurus would have been similar to Diplodocus, but may have been over 36 metres long and weighed up to 130 tons. This would have been the biggest animal ever to have lived. What did dinosaurs eat? Well, some dinosaurs ate only plants. Others ate only meat. Plant-eating animals are called herbivores, and meat-eating animals are called carnivores. Most dinosaurs ate plants. The huge sauropods, the largest of all the dinosaurs, are the best known. They had long bodies, tails and necks, and small heads with special teeth for grazing. With their long necks, they could reach up into trees. Fossils of the teeth and jaws are the most important clues. Narrow, curved, sharp teeth belong to the carnivores like Tyrannosaurus. Herbivorous dinosaurs have flatter, grinding teeth like Camarasaurus or sharp, nipping teeth like Iguanodon. Ceratopsians had beaks to help tear off leaves. Some dinosaurs had up to 2,000 teeth. Plant-eating dinosaurs ate most of the time to get enough nourishment. Diplodocus ate about a ton of leaves a day. The meat-eating dinosaurs' diet was much richer, so they didn't need to eat huge quantities regularly. Plant-eating dinosaurs swallowed stones to help them grind leaves up in their stomachs. Small reptiles, birds, fish and insects were all food for the dinosaurs. Dinosaurs never ate grass, which did not appear on Earth until after the dinosaurs had become extinct. Fossils of dinosaur droppings have helped scientists discover what dinosaurs ate, but which dropping came from which dinosaur? Many dinosaurs were protected by armor. This included hard plates, horns and spikes. Euplocephalus stunned its attackers with the bony club on the end of its tail. Carnivorous dinosaurs had sharp claws as well as sharp teeth. Both would have made good weapons. Some large carnivores like Tyrannosaurus may have used their heavy skulls as battering rams. Tyrannosaurus' teeth were more than 15 centimeters long and very sharp for slicing and tearing at flesh. No one knows what Tyrannosaurus used its very short arms for. They didn't even reach its mouth. It measured 14 meters in length and stood almost 6 meters high. Some carnivores were fast and would have chased other dinosaurs, perhaps even their own kind. They may have hunted in packs like hyenas. Small Coelophysis skeletons were found in adult Coelophysis. Large carnivores like Tyrannosaurus were too heavy to chase prey, perhaps fed off dead or slower moving dinosaurs. Could dinosaurs run? The arrangements of the bones in the ankles and feet of dinosaurs show that all except the sauropods and stegosaurs could run, and footprints prove that they did. A trackway made by Tyrannosaurus shows that it could have outrun a charging rhinoceros, perhaps reaching 30 miles an hour. The fastest of all was a small, two-footed dinosaur which left footprints showing that it could run at nearly 45 miles an hour, but we don't know which dinosaur it was. The great sauropod dinosaurs like Apatosaurus walked at a speed of only 3 to 5 miles an hour. Once, some footprints were believed to have been made by a hopping dinosaur, but they are now thought to have been made by a turtle swimming in shallow water. Footprints have been found showing a dinosaur with a missing toe and another with a limp. Scientists believe that at least the active theropods could jump, but there is no evidence from footprints. 99 out of 100 trackways show walking dinosaurs. In only very rare cases, marks have been found where dinosaur tails dragged along the ground. Generally though, despite the enormous size of some tails, they were held up above the ground and not just when running. Throughout the world, there are about 1,000 places where dinosaur tracks have been found. One of the most famous is at the Davenport Ranch in Texas, in rocks 100 million years old. There, and in nearby places, thousands of footprints have been found. Fossil footprints give us clues about the shape of the foot, as well as the weight and speed of the dinosaur. There are sometimes skin impressions too. One of the Texas trackways contains the footprints left by 23 sauropod dinosaurs, which seem to have been travelling as a herd. Many of them are quite small, probably youngsters. The larger members of the herd travelled in front and at the sides of the herd, the smaller ones being protected in the centre. Dinosaurs crossing muddy lakes or seashores left behind their footprints, just as animals do today. If the mud dries in the hot sun, the next tide or flood washes more mud into the imprints, which are then preserved. The dinosaurs which could run the fastest had 2 long hind legs and were small and slim. Hypsilophodon from England and Lesothosaurus from southern Africa were both herbivores that could run fast. Though many dinosaurs could run well, they may not have been able to run for long distances before becoming exhausted. Just as lions hunt zebras today, the meat-eating dinosaurs hunted the plant-eaters. The carnivores ran to catch, the herbivores ran to escape. Could dinosaurs swim? Like any land-living animals today, elephants, hippos and buffaloes, dinosaurs enjoyed a good paddle and a swim. It was once thought that the heaviest dinosaurs, like Brachiosaurus and Apatosaurus, were too large to support their own weight on land, and therefore had to live in the water. Scientists have now calculated that their large leg bones were strong enough to support them out of water. The long necks of dinosaurs like Mamenchiasaurus were once thought to be useful for breathing in deep water. Unfortunately, water pressure at those depths, 10 meters or more, would not have allowed the lungs to work. If Nessie was ever found, and proved to be a reptile, she would almost certainly turn out to be a plesiosaur, ichthyosaur or pliosaur. These were all marine reptiles and were not dinosaurs which only lived on land. Throughout the reign of the dinosaurs, the ichthyosaurs and plesiosaurs were very common in the seas and oceans of the world. There were many types, including the pliosaurs and elasmosaurs. The largest of all was an Australian pliosaur called Kronosaurus, which grew as large as 13 meters. Plesiosaurs have long necks, short bodies, and large paddle-like limbs, rather like modern sea lions. Ichthyosaurs look rather like modern sharks and dolphins. Despite the enormous size of some, there's no reason to suppose that any dinosaur would sink. One set of brontosaur footprints shows only impressions from the front feet. It seems that the dinosaur was floating in a lake and simply kicked itself along with its front feet. One species of Compsognathus found in Germany seems to have had flipper-like front legs. No one is sure, but perhaps they allowed it to swim extra quickly to catch prey or to escape from its own hunters. Many modern creatures like dogs, elephants, polar bears and even cows can swim. They don't need flippers or webbed feet, and dinosaurs may have been able to swim just as well. Dinosaurs with weak teeth, like the ankylosaurs, may have grazed rather like hippos or like ducks in shallow water. The long, hollow crest of Parasaurolophus was once thought to be a sort of snorkel used while feeding below the water. Could dinosaurs fly? Well, some small dinosaurs have skeletons almost identical to Archaeopteryx, the oldest known bird. The dinosaur ancestors of the birds must have developed the ability to fly or glide short distances. Archaeopteryx was discovered in Germany in rocks 150 million years old. Alongside its fossil bones are clear impressions of feathers forming 2 wings and a tail. Compared to modern birds, its muscles were weak and it was much heavier, but it could have flapped its wings quite well, and its bony feathered tail would have made a good rudder to help it maneuver on long glides through the air. Perhaps like many living animals, including frogs, squirrels and monkeys, small feathered dinosaurs began to jump, glide and parachute from tree to tree, chasing prey or escaping from danger. Reptile scales, like those on snakes and lizards, may have become feathery to help keep the smaller dinosaurs warm. Only later did they also prove useful for flying. Tyrannosaurus would certainly never have got airborne. Some carnivorous dinosaurs, though, like Compsognathus and Ornitholestes, were very small, lightly built with hollow bones and could run quickly. Perhaps they chased small lizards and insects and began to take to the air. Fossils of birds are very rare. Their light, hollow bones do not fossilize well. Examples that have been found include birds similar to large terns, ostriches, eagles, and the dodo. The dodo lived on the island of Mauritius in the Indian Ocean. Because it could not fly, it was easily hunted and became extinct by the end of the 16th century. Pteranodon lived on Earth at the same time as the dinosaurs. Pteranodons belong to a group of flying reptiles called pterosaurs. The skeletons of the earliest known flying reptiles are similar to ancient carnivorous reptiles alive before the dinosaurs. Their skeletons were light and perhaps they too, like the later feathered dinosaurs, climbed trees and learnt to glide. Longisquama glided through the air with its long, scaly wings. Did dinosaurs have babies? All living creatures reproduce, and dinosaurs were no exception. It's believed that, like almost all living reptiles, dinosaurs laid eggs. The first ones were discovered in the Gobi Desert in Mongolia in 1921. They were neatly arranged in nests and were discovered with skeletons of the small horned dinosaur Proceratops. Fossil eggs have been found with sauropods, ceratopsians, and a variety of other dinosaurs. When dinosaur eggs are found, it's not always possible to say which dinosaur laid them. However, they're very rare, and the majority of dinosaurs have left no fossil eggs. But most scientists assume that all dinosaurs did lay eggs. The largest egg found weighed 7 kilograms in weight. Unlike most modern reptiles, dinosaurs seem to have laid eggs with hard shells. Eggs that have been found whole are usually oval-shaped, blunt at one end with a wrinkled surface. In the case of Proceratops, they are about 20 centimeters long and laid in nests up to 30 or more at a time. Other eggs are usually between 120 and 170 millimeters long, as big as an ostrich egg. Eggs of the dinosaurs Orodromeus and Troodon have been X-rayed and contain the tiny fossilized bones of embryos. Now, even the fiercest alligator living today is a very caring parent, feeding and protecting its tiny young. The remains of Maiasaura dinochicks were found in Montana, and though their teeth show wear from eating, they were still in their nests. They must have been fed by their parents until they grew old enough to leave home. Scientists can only guess whether a fossilized dinosaur was male or female. In a few examples where many skeletons have been found together, some are bigger than others, perhaps the males. We can be sure that baby dinosaurs did know the difference. The smallest dinosaur skeleton is only 20 centimeters long, about the size of a blackbird. It's been called Musaurus, mouse lizard, but is in fact the dino chick of a yet unknown dinosaur. Other dinosaur babies found include Proceratops, Maiasaura, Psittacosaurus and Coelophysis. Some fossils of Chasmosaurus show that in herds they formed a protective circle around their young to guard them from attack. Were dinosaurs stupid? The original discoverers of Apatosaurus and Diplodocus were surprised at the small size of the heads compared to the bodies of the dinosaurs. They thought that with such tiny brains, the dinosaurs must have had little intelligence. Today, we're not so sure. Size for size, Stenonychosaurus must have been the brightest dinosaur. Its brain is similar in proportion to birds and even some mammals, and much bigger than crocodiles. Is this what Stenonychosaurus might have looked like if it had continued evolving? Brains control behavior and the senses as well as cleverness. The small carnivorous dinosaurs had large brains compared to the size of their bodies. As a result, they had excellent vision, could move quickly, and were good at learning how to hunt and catch their prey. For reptiles, most dinosaurs seem to have had quite large brains. The smaller, faster carnivores had the largest brains, though the largest of all was perhaps Tyrannosaurus. The stegosaurs had perhaps the smallest brains, about the size of a walnut. The brain of the Chinese stegosaur, Tojangasaurus, weighed only 70 to 80 grams. The sauropods score lowest in the brain stakes, but however small their brains were, they were obviously good enough for them to survive as a group for 150 million years. On average, crocodile and alligator brains are approximately the same size as similar-sized dinosaurs. The brains of living mammals are 10 times the size of similar-sized living reptiles. Sometimes when mud and sand surrounded a dinosaur's skull after death, it filled the brain cavity too. The result? A fossil brain. Different areas of the brain can be seen, as well as the bony passages for nerves and blood vessels. Brains do not automatically get bigger in proportion to bodies. It depends what dinosaurs did. The more active the dinosaur, the larger the brain needed to be to produce quicker reactions. How did their bodies work? The flesh and organs of all creatures rot away after death. To understand how the bodies of dinosaurs worked, scientists have to build up their ideas on very little evidence. Like modern animals, dinosaurs needed blood to carry oxygen, heat and food around their bodies. Their blood was probably much the same as our own. To pump this blood, the dinosaurs needed hearts. Those of the biggest dinosaurs must have been enormous to pump blood to heads as high as 25 meters above the ground. Blood, unfortunately, does not fossilize, but some bony passages for blood vessels do. Microscopic studies of dinosaur bone have shown that it resembles the bone of living, warm-blooded mammals, rather than the so-called cold-blooded living reptiles. This means that the dinosaurs may have been much more active than their living relatives. Some scientists believe that sauropod dinosaurs like Barosaurus might have had up to 8 hearts to help pump blood up their long necks. Reptiles today keep their bodies warm by sunbathing. This can limit their movement in cold weather, so most reptiles live in warm climates. Mammals and birds rely on their own bodies to release heat from food. If they were as active as we think they were, dinosaurs may have been able to do the same thing. Once the biggest dinosaurs were warm, they would probably never have cooled down. Uranosaurus had long spines running down its backbone. These would have been covered by skin to form a kind of sail. It could warm up or cool down by directing its sail towards or away from the sun. Muscles are attached to bones. Because of this, bones carry scars of where the muscles were once fixed. The size and position of these marks on dinosaur bones allow scientists to reconstruct the shapes of legs, arms, hips and shoulders. Living reptiles also give some good clues. Dinosaurs had holes in their skulls from the nostrils to allow for breathing. They probably used them for smelling too. Some dinosaurs, like Camarasaurus, had very large nostrils on top of the head. Scientists once thought that these helped the dinosaur to breathe underwater. The nostrils of the duck-billed dinosaur, called Saurolophus, are thought to have been covered by an inflatable pouch of skin. Perhaps like many birds, Saurolophus could blow this up into a large, colourful balloon to warn off rivals or to signal to the opposite sex. There's no evidence that any dinosaur had outer ears like elephants or even ourselves. Like modern reptiles and birds, dinosaur ears would probably have been visible on the surface of their heads. They would look like circular marks in the skin. The eyes of living reptiles are usually bright and yellow. They're not surrounded by white like our own. Scientists can tell from dinosaur skulls that most had large eyes and so could probably see very well. Gallimimus had very large eyes. Each eye was supported in its socket by a ring of bony plates, which are often fossilized. How do you find a dinosaur? Fossils are found in rocks formed from mud and sand left by water or wind. They're called sedimentary rocks. Identifying the right rocks of the right age is a good start to finding dinosaurs. All sorts of plants and animals lived with the dinosaurs, and their fossils are much more common. Ferns, snails, freshwater fish, shellfish and even insects. Recognizing the right type of rocks with the right type of fossils shows that dinosaurs might be around. Some scientists believe that less than 10% of dinosaur types that ever existed have been found fossilized. The most common fossils are found in rocks formed underwater, especially the seas or oceans. Dinosaurs only lived on the land and so are not so common. They are found in rocks that formed near rivers, lakes, seashores and also deserts. Fossils are usually found where the rocks can be seen, quarries, cliffs or mountains. Fossil hunters then hunt for odd bones sticking out of the rock, made visible by wind and rain. Baryonyx was discovered by a man who found only a single claw in a busy quarry. Most of the skeleton was found later by expert excavation. Excavating a dinosaur is not an easy job. After discovery, several tons of rock might need to be moved by diggers, bulldozers and pneumatic drills. Hammers and chisels might be used for more careful work before a bone can be removed. Some of the dinosaur fossils found earlier this century have still not been fully extracted from the rock in which they were collected. Before dinosaur bones are removed from an excavation, they are cocooned in plaster of Paris or foam jackets to protect them on the journey back to the laboratory. Bones may be cracked and only partly visible in their enclosing rock. They're taken to laboratories where the rock is carefully removed with special tools, and cracks are constantly being repaired. It may be years before all the bones are prepared. Only if the bones are in very good condition might they then be joined to make a skeleton. Though it's very rare to find a completely new dinosaur, Baryonyx is a dinosaur unlike any other, and it was found in 1982. In Canada, millions of dinosaur bones can be seen scattered in Dinosaur Provincial Park. 3 or 4 complete skeletons are found each year. Dinosaur skeletons in museums are often plaster casts moulded from the real bones. Dinosaurs are too precious to risk damage. Because dinosaur skeletons are rarely complete, model bones are often added to the real skeleton to make up for any that are missing. The first dinosaur to be put together was an iguanodon from Belgium. It was assembled in 1882. The bones were hung from scaffolding by ropes so that they could be moved until they looked right. Then they were supported by an iron frame. How do you become an expert? The study of fossils is called paleontology, old life study. Many years of learning are needed to become a paleontologist, but there are lots of ways to become interested in dinosaurs. You can collect dinosaur models, toys, games, and even postage stamps from around the world. All fossils are the remains of once living creatures, so biology is important. Mathematics and English will always be useful, and later, physics and chemistry. There are no courses, especially about dinosaurs. At university, you learn about different aspects of geology, rocks, minerals and fossils, and the processes that have made and shaped the Earth. You could also study zoology and learn about living animals before specialising in dinosaur studies. It helps if you live in an area where dinosaur fossils are known to occur, but you would still have to be very lucky. The commonest dinosaur finds are probably teeth. Start by making a collection of other fossils to get experience. Leaflets and books may be found in libraries, shops and museums. Make a catalogue in an exercise book to help you remember what the fossils are and what you know about them. A hammer and chisel are useful to split open rocks. Protective clothing is needed too. Gloves for hammering, goggles to guard your eyes, and a hard hat to protect your head, especially near cliffs. Never collect without the permission of the landowner. Never collect from cliffs or quarry walls. It's much safer to work on fallen blocks or waste tips. Don't be greedy. Leave some fossils for others to find. Replace your poorer fossils when you find better examples. Remove the fossil carefully. Wrap it in kitchen roll or toilet tissue. Make a note of when and where you found it. At home, clean away loose dirt with a dry brush. If this doesn't work, try brushing with a little water. When the fossil is dry, write a number on it for use in a catalogue of your finds. Store your fossil safely by making a tissue nest for it in a box or drawer. Model makers and artists must work closely with paleontologists if their models and pictures are to look right. Muscles are carefully drawn onto a skeleton outline and the skin added so that the basic shape is right. Visit your local museum and ask if there is a geologist on the staff. If you've collected fossils, someone may help you identify them. You may also be able to find out if there's a local geological society. Society members will include many enthusiastic collectors. Find out from them about the latest information on dinosaurs. Whatever happened to dinosaurs? There are no dinosaurs alive today. One of the great mysteries in the history of life on Earth is why such a successful group of animals should become extinct. Rocks about 70 million years old from all over the world contain dinosaur fossils. Amazingly, only 5 or 6 million years later, not a single dinosaur had survived. It's not always easy to tell whether rocks in one place on Earth are a little bit younger or older than rocks in other places, so we're not sure if some dinosaurs outlived others thousands of miles away. Certainly the last dinosaur groups included Tyrannosaurus and Triceratops. A bone-headed dinosaur, Pachycephalosaur, called Stygimoloch from Montana, USA, may have been the very last to survive, but only a few pieces of broken skull have been found. All the large marine reptiles, the mosasaurs and plesiosaurs, as well as the flying reptiles, disappeared. Also some types of shellfish, including the ammonites and belemnites, and huge numbers of microscopic marine plants vanished. The majority of plants and animals survived. These included the other reptiles such as snakes, lizards, crocodiles and turtles. Birds and the early mammals survived too, together with shellfish, corals, starfish, insects and land plants. Most scientists now agree that two things caused the death of the dinosaurs and many other creatures. First, the climate had been gradually cooling down. Second, around 64 million years ago, something catastrophic happened. Some people believe a huge 6-mile wide meteorite travelling at 60,000 miles an hour hit the Earth. A large meteorite hitting the Earth would throw up a gigantic cloud of dust. This would cut out sunlight for months, perhaps years, causing plants and animals to die. Some, like the dinosaurs, never recovered. In Mexico, fossil tree trunks have been found mixed up with rocks from the ocean floor. These are evidence of the huge tidal waves that a large meteorite would cause. Sadly, though there are occasional stories and legends, no one seriously believes that even a small dinosaur could have remained undetected. But dinosaur descendants are still all around us, the birds.